Hi students, in the previous class we studied about aliphatic amino acids. In this class aromatic amino acid. Okay, there are two examples of aromatic amino acid is there. First one is phenylalanine and second one is tyrosine. Next is heterocyclic amino acid. What is meant by heterocyclic? Heterocyclic compounds are organic compounds containing at least one element other than carbon atom within ring structure. Okay, in this case nitrogen is there. Okay, there are two examples of heterocyclic amino acids. First one is tryptophan and second one is histidine. The group present in histidine, the name of the group present in histidine is the imidazole group. Okay, the presence of indole ring is there in tryptophan. Okay, the group present in histidine is imidazole group and the name of the ring present in tryptophan is indole ring. Okay, clear. And finally amino acid. The classic example for amino acid is proline. The ring present in the proline, the name of the ring pyrrolidine ring. Okay, clear. Next classification of amino acid based on polarity and charge on R group. The properties of an amino acid are in large part depends on its side chain, which uniquely defines each of the 20 amino acids. Based on the polarity and charge on the side chain, the primary amino acids are allocated among three different subgroups. Okay. The first group is non-polar R groups. In the non-polar R groups, there are 8 amino acids. First one is alanine, valine, leucine, isoleucine, phenylalanine, tryptophan, methionine, proline. Second group is polar but uncharged R groups. Amino acids which contain polar but uncharged R groups. In this group, serine, threonine, glycine, asparagine, glutamine, tyrosine, cysteine. The third group is charged polar R group. In this group, both negatively charged and positively charged R group is there. Negatively charged R group, polar amino acids with negatively charged R groups. The examples of these negatively charged R groups are aspartic acid and glutamic acid, and positively charged lysine, arginine and histidine. Okay. അപ്പോൾ നമുക്ക് ഓരോന്നിൻ്റെയും ചില പ്രത്യേകതകൾ നോക്കാം. First one is non-polar R group. 8 amino acids are classified as having non-polar side chain. In proteins, these amino acid residues are usually buried in the hydrophobic interior of the biomolecule and are out of contact with water. These are hydrophobic. Okay. Amino acids with non-polar side chains tend to be located in the interior of the polypeptide molecule, where they associate with other hydrophobic amino acids. The non-polar R group thus fill up the interior of the folded protein and help give its three-dimensional shape. This is example for hydrophobic interaction between two non-polar amino acids. Okay, in the interior of the protein molecule. Next, polar amino acid with uncharged R groups. Side chains of these amino acids are uncharged and they have polar group, OH group, SH group, NH group that can form hydrogen bond to water. First is serine and threonine. For example, bear hydroxyl group of different sizes, serine and threonine. Glycine has hydrogen for its R group. Asparagine and glutamine have amide bearing side chains of different sizes. Tyrosine has phenolic group. Cysteine has a thiol group that can form disulfide bond with another cysteine through oxidation of the 2-thiol group to form cysteine. Okay. Side chains as site of attachment for other compounds. The polar hydroxyl group of serine, threonine and rarely tyrosine can serve as a site of attachment for structures such as phosphate group. In addition, the amide group of asparagine as well as the hydroxyl group of serine and threonine can serve as a site of attachment for oligosaccharide chains in glycoprotein. Thus, side chains a site of attachment for other compound. Example, attachment of phosphate group and attachment of oligosaccharide chains in glycoprotein. Okay. Formation of hydrogen bonds between polar group on the surface of proteins and the aqueous solvent enhances the solubility of the protein. Formation of hydrogen bonds between polar group on the surface of protein and the aqueous solvent enhances the solubility of the protein. Next category is charged polar R group. The basic amino acids have a positive charge on their R group at physiologic pH values because the R groups are protonated. Examples of basic amino acids are the lysine, arginine, histidine. The side chains of the basic amino acid accept protons. At physiologic pH, the R group of lysine and arginine are fully ionized and positively charged. In contrast, histidine is weakly basic and the free amino acid is largely uncharged at physiologic pH. The free amino acid is largely uncharged at physiologic pH. However, when histidine is incorporated into a protein, its R group can be either positively charged or neutral, depending on the ionic environment provided by the protein. This is an important property of histidine that contributes to the buffering role it plays in the function of protein such as hemoglobin. Okay. The basic amino acids have a positive charge on their R group at physiologic pH value because R groups are protonated. Examples of basic amino acids: lysine, arginine, histidine. Clear? Histidine is very important. The important property of histidine that contribute to the buffering role it plays in the functioning of proteins such as hemoglobin. Okay. The acidic amino acids have a negative charge at physiologic pH. Examples of acidic amino acids are glutamic acid and aspartic acid. The amino acid aspartic and glutamic acid are proton donors. Proton donors. Okay. Next, classification of amino acid according to metabolic fate. After the removal of amino group of amino acid, if the carbon skeleton can be converted to glucose, such amino acids are called glucogenic amino acids. Okay. If the carbon skeleton can be converted to ketone body, such amino acids are called ketogenic. There are two metabolic fates are there. Glucogenic amino based on the metabolic fate, there are two groups of amino acid. First one is glucogenic amino acid and second one is ketogenic amino acid, and third one is both ketogenic and glucogenic. During metabolism, part of the carbon skeleton of these amino acids will enter the ketogenic pathway and the other part to glucogenic pathway. Okay, but there are three groups: glucogenic amino acid, ketogenic amino acid, and amino acid with both ketogenic and glucogenic properties. Okay, metabolic fate. Examples are: leucine is purely ketogenic because it is converted to ketone body. Lysine, isoleucine, phenylalanine, tyrosine, and tryptophan are partly ketogenic and partially glucogenic. All the remaining 14 amino acids are purely glucogenic as they enter only into glucogenic pathway. Okay, leucine is purely ketogenic because it is converted to ketone body. Lysine, isoleucine, phenylalanine, tyrosine, and tryptophan are partially ketogenic and partially glucogenic. All the remaining 14 amino acids are purely glucogenic as they enter only into the glucogenic pathway. Next classification based on nutritional requirement. This is very, very important topic. Based on the nutritional requirement, first one is essential or indispensable amino acids. Second one, partially essential or semi-essential amino acids. Third one, non-essential or dispensable amino acid. Fourth one, conditionally essential amino acids. These are the four groups based on the nutritional requirement. Essential or indispensable amino acid. What is meant by essential amino acid? Their carbon skeleton cannot be synthesized by human beings, and so preformed amino acids are to be taken in food for normal growth. Normal growth and optimal health will not occur if one such amino acid is deficient in the diet. Okay, the definition is very, very important. Their carbon skeleton cannot be synthesized by human beings, and so preformed amino acids are to be taken in food for normal growth. Normal growth and optimal health will not occur if one such amino acid is deficient in the diet. Partially essential or semi-essential amino acids. They are not synthesized in sufficient quantity during growth. Growing children require them in food, but they are not essential for the adult individual. Examples: arginine and histidine. partially essential or semi-essential amino acid. What is meant by partially essential? They are not synthesized in sufficient quantity during growth period. Growing children require them in food, but they are not essential for the adult individual. Examples are arginine and histidine. These are the essential amino acids and semi-essential amino acid. Okay. Arginine, histidine are semi-essential. Isoleucine, leucine, threonine, lysine, methionine, phenylalanine, tryptophan and valine. These are the essential amino acids. അപ്പോൾ നമ്മൾ എസെൻഷ്യൽ അമിനോ ആസിഡ്സിൻ്റെ എക്സാമ്പിൾ ചോദിച്ചു കഴിഞ്ഞാൽ നിങ്ങൾക്കിത് മുഴുവൻ എഴുതി വെക്കാം. കാരണം അർജിനിൻ ഹിസ്റ്റഡിൻ ഈസ് എസെൻഷ്യൽ ഫോർ ഗ്രോയിങ് ചിൽഡ്രൻ. ഓക്കെ, ഇത് ഓർത്തിരിക്കാനുള്ളൊരു ചെറിയ കോഡാണ്. എനി ഹെൽപ്പ് ഇൻ ലേണിംഗ് ദീസ് ലിറ്റിൽ മോളിക്യൂൾസ് പ്രൂവ്സ് truly valuable. A for arginine, H for histidine, I for isoleucine, Le for leucine, TH for threonine, L for lysine, M for methionine, P for phenylalanine, TR for tryptophan, VA for valine. Okay. ഈ എസെൻഷ്യൽ അമിനോ ആസിഡ്സ് ഏതൊക്കെയാണെന്നുള്ളതും അതിൻ്റെ ഡെഫിനേഷൻ എന്തൊക്കെയാണെന്നുള്ളതൊക്കെ റിപ്പീറ്റായിട്ട് ചോദിക്കുന്ന ക്വസ്റ്റ്യൻസ് ആണ്. അതുകൊണ്ട് എന്തായാലും നന്നായിട്ട് പഠിക്കേണ്ട ഏരിയ ആണ്. ഓക്കെ. നോൺ എസെൻഷ്യൽ ഓർ ഡിസ്പെൻസിബിൾ. വാട്ട് ഇസ് മീൻ ബൈ നോൺ എസെൻഷ്യൽ? ദ റിമൈനിങ് 10 അമിനോ ആസിഡ്സ് ആർ നോൺ എസെൻഷ്യൽ because their carbons can be synthesized by the body. So we need not have to ingest these amino acids as such. However, they are also required for normal protein synthesis. These non-essential amino acids are required for normal protein synthesis. Okay. These can be synthesized by body, so we need not have to ingest these amino acids as such. ചില കുട്ടികളെ എക്സാമിന് ദീസ് നോട്ട് റിക്വയർഡ് ഫോർ നോർമൽ പ്രോട്ടീൻ സിന്തസിസ് എന്നൊക്കെ എഴുതി വെക്കാറുണ്ട്. അത് തെറ്റാണ്. ദേ ആർ required for normal protein synthesis. It is based on the nutrition requirement. Non-essential amino acids can be synthesized by the body. Okay. Examples are the remaining 10 amino acids. Okay. All body protein do contain all the non-essential amino acids. Okay. Conditionally essential amino acids. What is meant by conditionally essential amino acids? When a person is suffering from a moderate to severe chronic illness, person may lose the ability to manufacture enough non-essential amino acids and thus require supplementation. Chronic illness is a long duration illness. Example, tuberculosis, malignancies. These are the chronic illnesses. Okay. These amino acids are normally non-essential but become essential during times of physiological stress. Okay. During stress, pathological stress. Okay, physiological or pathological stress. Okay. These conditionally essential amino acids are arginine, glycine, cysteine, tyrosine, proline, and glutamine. Okay. What is meant by conditionally essential amino acid? When a person is suffering from a moderate to severe chronic illness, person may lose the ability to manufacture enough non-essential amino acids and thus require supplementation. These amino acids are normally non-essential but become essential during times of physiological stress or during disease time. Okay. Next is non-standard amino acid. What is meant non-standard? The compounds similar to basic structure of amino acid but do not occur in proteins. These amino acids similar to the compound similar to basic structure of amino acid but do not occur in protein. The non-alpha amino acids, beta-alanine, they found in coenzyme A and a part of pantothenic acid, a B complex vitamin. Beta-alanine. Taurine, they found in bile acids, modified derivative of cysteine, important in conjugation of bile acids. These are modified derivative of cysteine, they found in bile acids and important in conjugation of bile acids. GABA amino butyric acid, inhibitory neurotransmitter ആണ്. A neurotransmitter, this inhibitory neurotransmitter produced from glutamic acid. This is an important inhibitory neurotransmitter found in human body. Okay. Non-alpha amino acids, beta-alanine, taurine, gamma amino butyric acid. Okay. The last one is derived amino acids. What is meant by derived amino acid? And derived amino acids are no codon, there is no codon present. Codon ഉണ്ടാവില്ല. അപ്പം derived amino acids are modified after incorporation in the protein. 5-hydroxylysine, 4-hydroxylysine, and methylysine, and formylmethionine, gamma-carboxyglutamic acid. These are modified after incorporation in the protein. As already stated, 20 amino acids are commonly found in protein. In recent years, a 21st amino acid, namely selenocysteine, has been added. Selenocysteine is an unusual amino acid containing the trace element selenium in place of the sulfur atom of cysteine. It is found at the active site of certain enzymes or proteins. These proteins are known as selenoproteins. Example, glutathione peroxidase. Incorporation of selenocysteine into the protein during translation is carried out by the codon, namely UGA. Pyrrolysine, this is 22nd amino acid. The stop codon UAG can code for pyrrolysine. Okay. The recent amino acid, first one selenocysteine and pyrrolysine. Okay. Thank you.